Hello everyone, welcome to my programming club. Today we will be solving another Leetcode weekly contest problems. So it is today's weekly contest 367. Now without further delay, let's move towards the first problem of the contest. So this is the first problem of the contest. The first and the third problem are exactly similar. The statement is similar. The only difference is that the constraints here are higher. So as you can see, the length of the nums array here is of only order 10 raised to power 2, and here it is of order 10 raised to power 5. Okay, so here a n square solution will not work, here it will work. So anyhow, we will be solving it in the most optimal way possible, so that the solution will be accepted for both of them. So let's read the problem statement. So the problem's name is find the indices with index and value difference, part 1. So you are given a zero indexed integer array nums having length equal to n and an integer index difference and an integer value difference. So your task is to find two indices I and j, both in the range of 0 to n minus 1 of the range is of the indices of the array of length n. It is a zero indexed or zero based indexing that satisfies the following conditions. Absolute value of two indices should be greater than or equal to index difference, and the value of the elements at those indices, absolute value of the difference of elements at those indices, should be greater than or equal to value difference. So you have to return an integer array answer where answer will represent any two such indices. Okay, and if it's not possible, you will return -1 comma -1 as your answer array. Okay, and let's have a look at the constraints. So the constraints are that the order of the length of the nums array will be of order 10 raised to power 2, and the elements in the nums array will be of order 50, and index difference will be of order 10 raised to power 2, and value difference will be of order 50. So this problem is also same, but the constraints are here are larger. So the value difference, so the value difference is of order 10 raised to power 9. Index difference is of order 10 raised to power 5. Length is of order 10 raised to power 5, and elements values are of order 10 raised to power 9. Okay. So how we will be solving this problem? What we will do is, for each index, starting from index difference value, we will keep minimum and maximum values of all elements or element at each index. Starting from the index difference value, we will keep minimum and maximum values of all the elements which are at least index difference ahead of them. What I mean to say is, for example, let's say the index difference is this much. So starting from this very index till the very last index, you will, for each of these indices, you will keep track of the minimum and maximum values of elements at least this distance before them, index difference before them. So let's say this index is 5 and index difference is given to be 2. So starting from 5 minus 2 to 0, you will keep track of what is the minimum and maximum value. So starting from here, let's say 3 to 0, you will keep track of minimum and maximum values. And if from either of these minimum and maximum values the following condition satisfies, what is the condition? Either let's call this particular value as element. Either this condition satisfies element minus minimum value is greater than equal to value difference, or if this condition satisfies maximum value, okay, minus element value is greater than equal to value difference, then you have found out the pair of indices that is required and you will return them. More will be clear in the coding part. It, okay, so initially minimum element index and maximum element index will be pointing to 0. Min and max value index will be pointing to the starting index. Then starting from index difference index in the given array, you will keep updating values of min element index and max element index. And if either of these two conditions satisfies, if the value condition for min element index satisfies, then you will return the pair of indices, current index and main element index. Okay, and if the value difference condition, you can say, for max element index satisfies, then you will return pair of current index and max element index. Okay, so that's what you will be returning. And if you do not if you didn't find such pair, you will return -1 comma -1 if the desired pair satisfying the conditions of value difference and index difference is not found, then you will return the following value. Return the vector array or say vector containing following value. Okay, so let's try to submit once for the sample test cases. Submitting for final evaluation. As you can see, it's getting accepted. So these two particular questions are solved. These two are similar questions, so we have solved them for both of the constraints. Okay, as you can see, this solution is also getting accepted for the third problem also. Let's solve the second problem. Second problem of the contest names is shortest lexicographically smallest beautiful string. So you are given a binary string s and a positive integer k. A substring s is beautiful if the number of ones in it is exactly k. Okay. For example, let's say this substring is given to you, and let's take another substring. Let's say this substring is given to you. Now let's say k is given to be 3. Here the number of ones in this particular substring is 4 and the number of ones in this particular substring is 3. So this particular substring is beautiful and this is not beautiful. Okay. So let length be the length of the shortest beautiful substring. So let's say there are other beautiful substring possible also. Let's say this is the substring of which is beautiful also. Its length of this particular string is, as you can see, 5 and this particular string is 3. So this is smaller length. Okay. So let length be the length of shortest beautiful substring. Return the lexicographically smallest beautiful substring of string s with length equal to len, where len is the shortest length of the shortest beautiful substring. Okay, if s does not contain a beautiful substring, return a empty string. Okay, this is what you have to return, and then it's mentioned what is lexicographically larger and smaller values. you can read it out. And it's basically that according to the, if you go value by value, the first value, that then they both of the strings will differ. If let's say these two are taken as example, then ABCD is lexicographically larger than ABCC, because the first value at which they differ is this particular D, and last character, which is here C and here D. So D is greater than C, so this particular whole string is lexicographically larger than this one. Okay, so let's have a look at the constraints. So the constraints are pretty small, even our n cube solution will work here. N cube solution will have, let's say, time complexity of 10 raised to power 2 whole power 2. Okay, and it will be nothing but 10 raised to power 2 into 10 raised to power 2 into 10 raised to power 2, which is 10 raised to power 6. Okay, and it is lesser than 10 raised to power 8 limit of operations that your solution is allowed to perform. If the number of operations of your solution happens to be smaller than this limit, then your solution will be getting accepted. Otherwise, you may get a TLE, time limit exceeded, and your solution will not be accepted. Those of you who are not familiar to this limit concept of operations, number of operations, I will be providing a link describing how the time complexity of accepted solution varies with input size. Okay, a link of article describing this will be provided to you. So let's see how we will be solving this particular problem. Basic approach here will be that will be getting accepted is, we will generate all the substrings, generate all possible substrings, how we will be generating, we will be using two nested loops. One will be for left pointer and another will be for right pointer, say. Then you will be using substring function, which itself takes off n time. So both of these loops will also be taking off n time, and since the whole time complexity will be order of n cube, where n is the length of the given string. Okay, which is of order 10 raised to power 2. So 10 raised to power 2 whole power 3 will be 10 raised to power 6, which will be lesser than 10 raised to power 8 operation limit. So your solution will be getting accepted. So once you have generated all the possible substrings, this will be your step 1. Then in another step, what you will do is, step 2 will be to separate out all substrings having k occurrences of 1 in them. Okay, then step 3 will be to and store them in an array. To sort the array, in step 2, and return a substring of smallest length, which is also lexicographically smallest. Okay, this is how you will be solving this problem. Now let's have a look at the solution. So this will be the answers array that you will be, so, or let's call this substrings array. It will contain all the possible substrings of the given string. Okay, and then once you have here you will generate all the possible substrings. Okay, it will take order of n cube time complexity, where n is the size of the given string. Okay, and then what you will do is, this will be your second step to separate out all the strings having exactly k occurrences of 1 in them. Okay, once you have done with it, the next step will be to sort the substrings. The next step will be to sort the substrings such that the 0th index of the result array will be containing your answer. Okay, at last, if let's say the size of the results array is greater than 0, result array is greater than 0, then you will return its element at its 0th index. Okay, and if that's not the case, then you have not found a substring satisfying the conditions given in the problem, and you will return empty string. Okay, so that's pretty much it from my side. If you are still having any doubts, please feel free to ask them in the comment section. Also, for the last problem of the contest, I was not able to solve it in that given time constraints of the contest. So I will be solving it and uploading it in a separate video. So thanks for watching. If you are still having any doubts, please feel free to ask them in the comment section. Thanks.